Okay, the second derivative test. Now, there are three possibilities here. So you can either have one, f double prime of c is bigger than 0. 2, f double prime of c is less than 0. Or 3, f double prime of c is equal to 0. Okay, so if f double prime is bigger than 0, what does that mean? It means that my derivative is increasing. My first derivative is increasing as I go from left to right. And this corresponds to a local min at x equals c. Okay, the idea is that if you have a critical point, let's say this point here is a critical point, and the second derivative is positive, so you can think of that as concave up, right? And we just say, well, that is a min. Similarly, we have a local max at x equals c if the second derivative is negative, because we have a critical point, and the second derivative is negative, meaning concave down. So I don't know about you, but that looks like a max to me. I cannot complete this for some reason. Too much coffee. Anywho, now the last case is the bad news case. If f double prime is 0, then we have received, or obtained rather, no information. Okay, so this is called the second derivative test. It gives you a way to test critical numbers to see if they're maxes or mins. And let's see this in action with the following example. So what we'll do is we will find the critical numbers, pause and copy if need be, find the critical numbers, and then test them. So my CNs, well, I need f prime. F prime of x is 4x cubed minus 12x squared. Factor that, take out a 4x squared. What do you get? X minus 3. So my CNs are x equals 0, coming from here, and x equals 3, coming from here. Because again, to find the critical numbers, we set that equal to 0. So using the second derivative test, well, I need my second derivative. I'll work from here, getting 12x squared minus 24x, factoring out at 12x gives me x minus 2. So what can we say about our critical numbers? Plug them in here. What do you get? F of 0 is 0. F of 3 is, well, with the factored form, I can quickly see that it's positive times positive. So that's bigger than 0. Okay, so here we have a local min. So therefore, local min at x equals 3. And here we have no information, unfortunately. No info. What can we do with this no info scenario? Well, we can go back to our first derivative test. We can use the first derivative test. So that's looking at this number line. What's happening? What is happening to f prime near 0? So my f prime in nice factored form is right here. So if I plug in, say, -1, f of -1, I get positive times negative, so that's less than 0. And if I plug in, say, f of 1, you get positive and negative again. So this is negative, negative, negative. Okay, so the function is decreasing before 0 and is decreasing again afterwards. So something like it's going down, 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 flat momentarily. Flat momentarily there, and then going down again afterwards. Okay, so this is neither a max nor a min. So neither max nor min at x equals 0.